Okay, hope you're having a good day today. We're going to be talking about logarithms, and basically, the basic idea here is today we're going to focus on this top part, write and evaluate logarithms. We'll graph tomorrow, okay? But right now we're going to be able to write and evaluate a logarithm. So you should be saying, hey, Mr. Roderick, what the heck's a logarithm, right? So logarithms are basically the inverses of exponentials. Okay, inverses, and we already know what inverse means. Inverse is when I take a function and or a dot or whatever and flip it over the line y equals x, right? So we know that. So we know inverse. We know uh, we know exponentials, what those look like now. So we'll go ahead and start talking about logarithms. Okay, so this is your basic guy here. This is what we want to get to. Okay, at the end of the lecture, this is what you should be able to handle. An exponential equation, 2 to the third equals 8. Okay, and turning it into a logarithmic equation, we're basically going to make 2 our base, and so it's going to go to the left. The exponent is the answer, so it goes to the right, and the 8 moves into the center. Okay, so it's like a little left, right, center going from exponential to logarithmic. But now, uh, but those are just the mechanics, though. Okay, that's the mechanics. What we want to know is kind of know, well, what does a logarithm mean? Okay, so we're going to start talking about base 10 going through that worksheet that I gave you today. Okay, so if I represent these numbers right here, that's quick and easy for us, right? This is 10 to the first, so 10 equals 10 to the first. 1,000 equals 10 to the third, and 100 equals 10 squared. Okay, well, these exponents here are basically logarithms, okay? And I will show you their logarithms in base 10. All right, so now let's go ahead and move forward here. And now this is still 10, whoa, 10 equals 10 to the first again, and 1,000 equals 10 to the third. 99. Oh no. I know about. Okay. So I can say 10 to about the second, right, equals 99. Okay, so I can estimate. Now, if I want to get specific, I can grab my calculator at this point, right? We all know how to do that, where we can go ahead and grab this guy and say, okay, 10 to the x goes on line 1, 99 goes on line 2, and then I think about my window. I say, well, this should happen. I know x has got to be a little bit more than 2, and y has got to be, well, 99 is where I'm looking, so I'm going to make it big, make it 200, and graph, and find the crossing point. Okay? All right? When you find that crossing point, you get 1.99. Let's see. What exactly? Yeah, 1.99 to the nearest hundredth. Okay, so you can say 10 to the 1.99 equals 99. Okay, and that's how you're going to be thinking about logarithms. So let's go ahead and look at fives. 5 squared is 25. 5 to the third is 125. Oh man, 5 to the fourth. I know that's 625. Oops. So it's a little bit less than that. So 5 to the 3.9-ish maybe. Okay. And we can go to our calculator and find that number again, repeating the process that we did here. We could go set up our equation. 600 equals 5 to the x. 5 to the x goes on line 1. 600 goes on line 2. And uh, so forth, and we can solve that guy there. Okay? Now, there's got to be a better way, Mr. Roderick. Yes, that's our logarithms. We're going to use logarithms, okay, to be able to express this a little bit easier and quicker. All right? So basically, if 10 to the x equals 100, let's just do a quick algebraic way of solving this. 10 to the x equals 100. Well, 10 to the x equals 100 is 10 squared. So quickly and easily you can say x equals 2. And really right here you're saying 10 to the 10 in this original spot, what you're saying is 10 to the what is 100. Okay, and that 10 to the what is how you're going to set things up in logarithmic form. Okay, so basically this is the idea of saying, well, this is log base 10. So this 10 is the base of 100 equals 2. Okay, this is our left, right, center game. In other words, 10 to the x equals 100, so I can say log base 10, so 10 squared is 100. Okay, this statement says log 10 log base 10 of 100 equals 2 is the fancy math way of saying it. But really what I'm saying is 10 to the what is 100. 10 to the 2 is 100. Okay? All right. And we can go ahead and kind of do the same thing with 10 to the third equals 1,000. So I can rewrite that as log base 10 of 1,000 equals 3. So the exponent is the answer. You hear people say the exponent is the answer. Okay? All right. So now let's go with 5 to the x. 5 to the x is 125. Okay? So basically 5 to the x, 125 is 5 to the third, so x equals 3. So we can say kind of the same thing, log base 5 of 125 equals 3. Okay? Log base 5 of 125 is 3. All right, so let's keep rolling along here, and let's look at this guy. Okay, so now you say, ah, man, this is the one that's not right on it. Okay, so I got 10 to the x equals 99, and right now I just have log base 10, 99 equals x. 10 to the what is 99? Well, I don't know exactly, but guess what? Your calculator knows. Your calculator knows. So let's, in our calculator here, let's go ahead and basically see the log button down on the left by the 7. So log, it is working, your calculator is working in base 10. So log 10, 99, bam, 1.995. Okay? So x equals 1.995. So let's work with some other numbers here while we got this calculator up. Let's think about, I don't know, 400. So log 400. Now before I hit enter, I should say, okay, uh, 10 squared is 100. 10 to the third is 1,000. So it better be in that range between 2 and 3, 2.6. So what we're saying is 10 to the 2.6 is 400. Okay, let's think of 7,568. Okay, good enough. Wait a minute, I have to hit log first though. So log of 7,000, whatever, 658. Okay, basically I'm saying before I hit that button, I should say, okay, 10 to the third is 1,000, 10 to the fourth is 10,000, 3.88. Okay, so 10 to the 3.88 is 7,658. That's what that statement says. Okay? All right. Now, this is kind of beating a dead horse at this point, I hope. 10 to the x equals 50. That means log base 10 of 50 equals x. So I'm saying 10 to the what is 50. 10 to the what is 50. So I'm going to go log 50, log base 10 of 50, and whammo, 1.69. Okay, so 10 to the 1.69, 1.699 is my number. Oops. 1.699. Okay. All right. So what are we going to be able to do? We're going to be able to do stuff like this. Write in exponential form. So it's in logarithm form. So log base 2 of 64 equals 6. I'll say it again. Log base 2 of 64 equals 6. Okay? So if I want to write this in exponential form, 2 to the what? 2 to the what? 2 to the 6th equals 64. 2 to the 6th equals 64. Now, so we got to be able to go the other way. Go to logarithmic form from exponential. So log base 3, right? This goes to the left. This exponent goes to the right. And the 1/3 goes to the center. Okay? Let me make sure that you see that that's 1/3 up here. Okay? Log base 3 of 1/3 equals -1. Okay? Looks like that, so the notation's a little sharper for you there. Okay? And let's go ahead and move to the last little spot here. Evaluate. Well, log base 4 of 1 is what? Well, anytime it says what and I don't have anything, I'm going to fill in an x. So 4 to the x equals 1. Well, 4 to the anything, well, 4 to the 0 is good there. So x equals 0. That's it. That's all you do for that. X equals 0. Okay? Now, what is the value of x? So now I'm going to put the x in the middle there, and I go, okay, I don't like this logarithmic statement. I've only been dealing with it for a few minutes here, so I'm going to put it back into exponential. 2 to the what? 2 to the 5th. 2 to the 5th equals x. 2 to the 5th is 32. X is 32. All right? And we're going to work on that a lot in class tomorrow, but that's the basic idea of what we're going to be able to do when I say write exponential and logarithmic formula or equations, and then also evaluate exponential equations. Okay? Thank you very much. Hope you're having a great day.